What's up y'all, ChrisRL here, and it's finally time we start covering the RPG item system. So I'm starting here with an empty Unity project, where I've just created some folders and an assembly definition file to organize our code. And we'll begin by creating a few interfaces. So I'm going into the right-click menu, and then the scripting submenu and choosing empty C# script, rather than monobehavior script. And the first interface I'm going to make is IItem. As a little pro tip, if you didn't know by the way, if you fill out the root namespace field in your assembly definition file, every script that you create via the right-click menu in Unity will automatically include that namespace. So for the IItem interface, let's change it to be an actual interface and not a class. And an item is going to be, in its most basic form, just a collection of an icon, a name, and the maximum number of stacks that it can have. The second interface I want to define, and we can do it directly here through VS Code's menu rather than going back to Unity, is going to be ItemDefinition. And this one won't seem very useful for a while, but it's going to become important later when we start implementing concrete implementations. But for now, it's only going to define an ID, and I also want our item interface to reference an item definition. So if you think of this purely in Unity terms, the item definition will be the scriptable object where you define item properties in the editor, and then the item will be the actual runtime class that will be created based on this item definition. But I want to define the most basic version of an item definition as an interface rather than a scriptable object directly, because that's more flexible. You may not want to be tied to scriptable objects specifically. Maybe you want to parse item definitions from a JSON file or a CSV file or anything else. Just a concrete example to make the distinction between item definitions and items clearer. Let's imagine we have a game where items can be generated with random stat values. The definition is where you would define how many stats each item can have and the range of values each stat can have. For example, let's say the values can range between 20 and 50, and then the item is the object that gets created after you process the definition and you generate a concrete item with exact stat values. Let's say an armor piece that has 47 agility and 39 strength. And let's make also a new struct to represent an item stack. I want this struct to be read-only, and an item stack will be simply an item and an amount for that item. For convenience, I'm going to add an isEmpty property, and this is just going to return true if the item is null or the item count is 0 or less. So an item stack can be empty, that's completely valid, and an empty item stack just means that the item is null or the count is 0. If we implement things properly, both of those things will always happen at once. We won't be able to have an item stack where the count is larger than 0 but the item is null, or vice versa. But just for safety, we consider the item stack to be empty when either one of these conditions is verified. So for the constructor, the simple implementation is that we would just assign the parameters to the read-only public variables of the item stack. But once again, to be safe, I want to check if the parameters represent a valid item stack and only assign them in that case. Otherwise, we force the item stack to be empty. We can also add an additional constructor that just receives an item and defaults the count parameter to 1. To make item stacks a lot more convenient to work with, let's add a few methods here. So what kinds of operations can we do with item stacks? You can add things to an item stack, or you can remove things from an item stack. So let's implement two public methods that return bool, one called TryAdd and another called TryRemove. So the TryAdd method will receive an item stack and I'm going to declare it using the in keyword, which simply means that this variable will not be able to be modified inside the function. So we will always have access to the original stack that was received, and then it will return as an out parameter the result of attempting to add something to this stack. But if we think about it, when you try to add something to an existing stack, you may be able to add some of the items, but not all of them, because it would go over the maximum number of stacks. So that means sometimes we can have partial adds, so we also need to return the remainder of the add operation. And then let's also add an override for the maximum number of items that can be in a stack, even though the item interface already defines how much it can stack with itself. I still like having the option of being able to override that under certain special conditions in the game, and having items stacking more or less than they normally do. So for the default case, if the TryAdd method fails, then we return false. The result of the operation will be the stack exactly as it is, and the remainder will be the stack we try to add also exactly as it is. Okay, but what determines if attempting to add something to a stack is successful or not? Well, the first thing is that this only works if the stack we are adding is not empty. So its item cannot be null and it needs to have more than 0 items. So if we've established that the stack we are trying to add is not empty, and then a stack that isn't empty can only be added to a stack that is empty or already has the same item that we are trying to add. So if the stacks are compatible, then we have to determine what is the maximum count of items that can exist in this stack. And remember, since we allow the option to override the default max stacks of the item itself, then we just need to make sure that we either use the overridden value, or if it hasn't been overridden or has been overridden to something that doesn't make sense, like a negative number, then we just default to the maximum number of stacks defined by the item itself. So if the current number of items of our existing stack is not already maxed out, then we can merge these stacks together. So here we simply add the number of items in each stack together, and then we subtract from this the maximum number of items, which is going to give us the amount of items in the remainder stack. And here it's okay if this goes to 0 or below 0. That just means we were able to add the entire stack and the remainder will simply be empty. That's okay. And then the actual amount of items in the resulting stack, we'll check whether or not the remainder is empty, because if it isn't empty, which means the remaining count is larger than 0, that means we weren't able to add the whole thing, so we need to stop at max count. Otherwise, if there is no remainder, then we did add everything, so we just use the sum of both stacks. And then the result is going to simply be instantiating a new item stack with the item, and here we've already established that the stack where we are either has a null item or the item is the same as the stack we're trying to add. So stack.item is always the correct item of the resulting stack. And this one is going to have result count, while remainder is going to have remaining count. And we return true here. For the TryRemove method, we don't really remove an item stack from another one, we just remove a certain amount of items. So it only makes sense for the first parameter to be the amount that we want to remove. And then we also want to return the result, or in other words, how many items are left in this stack after we remove count items. And we can also return an item stack that represents the actual amount of items that got removed. So it only makes sense to remove something from a stack if we're trying to remove more than 0 things. The number of items we're trying to remove also needs to be smaller or at most equal to the exact amount of items that we have. And also our item can't be null. So the result will simply be a new item stack with the current count minus the amount that we're trying to remove. And it's fine if this goes to 0, that just means the stack becomes empty. And for the removed stack, it's just the exact amount of items that got removed. So in this case, we return true. Otherwise, the result stays the same without any changes. Removed stack is simply the default item stack, which just means item equals null and count equals 0, and it returns false. I also want to implement the IComparable and IEquatable interfaces. When implementing the IEquatable interface, I think it's also good practice to override the object equals and get hashcode functions. I also want to implement an override to the toString function just for debug convenience. And since we already have the equals function, there's basically no reason not to add the static equals operator. For the compare2 function, first I want to compare both items, and then if they result in an equal comparison, I want to compare the counts. But first we must guard against the cases where items are null. So if this stack has a null item, if the other stack's item is also null, then we consider them equal. If the other item is not null, then we consider the other item as higher in the comparison. Otherwise, if the current stack is not null, but the other one is, then we consider this one higher, so we return negative here. If we've already validated that both items are not null, then we can compare them. However, the item is just an interface, so it doesn't have a compare2 method, which means we need to add it. But just to finish off this function, if the result of the comparison of both items is equal, then finally we compare the count and we return the result of that. So for the item interface, I want to make that interface implement the IComparable interface with generic parameter IItem. We don't actually need to implement anything yet because these are all just interfaces, but now in the item stack, the compare2 function becomes available for items. And with this, we can start implementing what we could call the inventory, but I'm actually gonna go for a more generalized name, and I'm going to call it ItemContainer. But that is something for the next episode. Thank you for watching, and I hope to see you again next time.